Hello everyone, happy Halloween. So in this video, I want to demonstrate how to apply an ML algorithm to new real-time 5-second bar updates. So I want to keep it very general where this will apply to any type of situation where you have a new 5-second bar and you can have many algorithms. So I'm going to have this abstract class on bar algo, which basically will implement such an algorithm, and there could be many of these algorithms. And the idea is on every 5-second real time update, you're going to run the algorithm. For this specific video, we're going to keep it very simple, and we're going to implement something called simple ML by cell algo, which will implement the abstract class on bar algo. This algorithm will just be a very simple algorithm based on the triple barrier method, where if you remember my video, this is from Lopez De Prado. But if you remember my video, the triple barrier method is, let's say you're at this time, you try to predict if you're going to be, let's say, 2 standard deviations above the current value before you get to 2 below, or you're going to run out of time. In our case, we're not going to have the vertical barrier for this simple example. We're just going to have a take profit here and a stop loss here. For our example, we're going to assume it's 10 cents above the close and 10 cents below the close, just to make the math, just to make the demonstration easier. But you should have real take profits and stop losses based on some statistics. Personally, I never use stop losses. I probably should. Anyways, this is just what we're going to do. So every 5 seconds, we're going to make a prediction, whether we go up or down, and we're going to buy and sell based on that prediction. But it's going to be a long only algorithm. So the initial thing will be a buy always. We're not going to short, but the buy will have a bracket with the take profit and stop loss. Okay, so let's get started. Okay. And I just want to say we're going to be very simple, no order cancellation, no order modification, no doubling down. All these things I always do. I always adjust price targets, change things, that sort of thing. But we're going to keep it very simple. And this is just going to be our simple ML by cell algo, and it's going to be one type of on-bar algo. Later, we'll have other on-bar algos. It'll be like different options strategies, something I call a free call rolling strategy, which was my stupid strategy, maybe combo strategies that are still on bar. Usually I would have a bar algorithm controller, which will let me handle those many strategies and how they work together. But whenever there's a new update to the bar, you will run all of these strategies. But in this video, we're not going to have the controller. We're just going to have the algorithm itself. And also, I want to say this is based on a stock. So the 5-second bars are based on a stock, but your trading can be based on an option or any other thing. But the bar updates are based on a single stock. Okay, so let's get started. So first things first, let's just remove the annoying warnings. This notebook might take a little bit of time to run because I lowered the power of my computer because I had this really annoying fan noise. So hopefully the fan noise is gone, but hopefully also it'll run fast enough where we can get through this entire video. So first, now we're going to connect to Interactive Broker. So from IB async import star. IB equals IB, the usual stuff, util.start loop. It's needed for Jupyter, IB.connect. See, I don't have any power, so it doesn't let me do autocomplete. Client ID, let's say 0. And am I connected? Oops. Great. So I connected to IB. Okay. So let's again review the big picture. So the big picture on these on-bar algorithms is every 5 seconds, we're going to get a new real-time bar. We're going to create these aggregate bars, which are like bigger sizes, because usually you're not going to use 5-second bars to make some sort of prediction. You're going to maybe use I don't know, every $100 million traded is going to be a bar. And you can have it go backwards in time, where the most current bar is the last 100 million traded. The bar before it is 100 million traded before it, and so on. But if you're using time bars, you can have stuff like you know what? I'll get to that in a second. But basically, the idea is we're going to need real-time bars and historical bars, and we need enough data where we can calculate our features in full. So let's say I am going to use 5-second type bars, and one of my features is RSI 780. So the 780 period RSI. Since there are 78 5-minute bars in a day, assuming regular trading hours, we're going to need 780. So we're going to need 70. So there's 78 5-minute bars in a trading day. So we're going to need 10 days worth of historical data if we use that feature. Okay, so you need enough depending on your situation. I just wanted to make a quick note that usually I organize this by having a data class to abstract this away. And also I want to say be very careful with your logic that like you're not missing bars. So let's say you get the historical data before the live bar data. That could be a problem because it takes maybe a few seconds, maybe more than 5 seconds to get like the first live bar. So you could be missing some data. So be very careful with that sort of thing. And also sometimes if you're doing real-time bars with use regular trading hours, then you'll have no values in it if you define it ahead of the trading day, in my experience. But okay, sorry for my rambling. The big picture is you get the data, which is a combination of historical bars and real-time data, and then you put the fat of your algorithm in the on-bar update, that's where you implement your logic when a new bar arrives. Okay, so, and I just wanted to make a small side note. An easier thing to do, for example, is just to use historical bars with keep up to date equals true for the last historical bar. But that's not that robust if you have an internet disconnection. So let's not do that approach in this example. But anyways, let me stop rambling and show you practically what we're going to do. Okay, so let's first define the stock of the contract we want to trade. So let's trade AMD because I lost a lot of money on AMD. Although I lost more money in super microcomputers. But yeah, smart currency equals USD. Let's qualify the contracts. Stock. I usually use regular trading hours as true because you get some weird things if you use like other hours. There's especially at like 8 p.m. Eastern. There's some crazy like weird orders. So I usually use regular trading hours as true. But here, because I'm pre-market, I'll use the false just to show you guys the concept. So I do rec, and remember you should do this real-time bars before the historical bars so you won't have a gap in your data. So I have contract equals stock, bar size, it's always 5 seconds, but I don't know why you have to add that. What to show is trades, and now because we're pre-market, I'm going to do use regular trading hours as false. Okay, so these are the real-time bars. So you can like click, you'll see you have none at first, and then eventually you'll have some. You can do util.df to see how they look, and it keeps adding every 5 seconds. Okay, great. So now we're going to get the historical data. So like data in the past. So I'm going to use 11 days worth of actually 33 days worth of data. So I'm downloading it, and while I'm downloading it, this is the historical data in the past. I'm going to explain, and this, I have other videos on how to get historical data, so I won't go through it. But basically, I'm looping over the number of periods, 11 periods, requesting historical data for the contract, going backwards in time, starting with like an empty string, and then getting the earliest date, and then using that earliest date in the next part of the loop, and so on, and then getting a list of bars, saving it into a data frame, that sort of thing. Okay, so I don't want to get into too much detail. I have a lot of videos discussing this thing, but these will be historical bars. Okay, so now let's talk about the real meat of the thing. When a new bar happens, when you get an update to this real-time bar thing, you're going to want to have a callback called on bar update. So like when a new bar arrives. And what you're going to do with this as a new bar arrives, what you're going to do is you're going to update your dollar bars, your volume bars, your time bars, or whatever you use. Okay. So I personally usually use some sort of form of dollar bars. So that's your first step to get like the bars you're going to use for your features. Step 2 is you're going to extract features. These are features you're going to need in your ML model. Step 3 is you're going to make a prediction of some sort. So like, are we going to go above 2 standard deviations, below 2 standard deviations, that sort of thing. But the general thing is you're going to make some prediction. It can be many different types of predictions. So that's why I kept it a little bit more general. Okay. And then you have a get action function. So I just wanted to note you can have many get action functions, one for each algorithm. In today's video, we're just going to do one for the buying the stock and then having a take profit and a stop loss. But you can have many get actions. You can have like many different types of algorithms in this thing. So that's why I try to keep it general. But in this video, we're just going to have if the prediction is above a buy probability threshold and the closing price is below a max price you're willing to buy the stock at, and you have no active trades, meaning we're only going to allow one trade at a time, you're going to submit a buy bracket order. You could also add things like to make sure, let's say you finished your bracket order, you bought the stock, and then you sold afterwards. You can also have like some condition where the next order, so you have no active orders, but in theory you can buy a stock and then sell it, and then the stock goes up $20 and you buy again. You might want to guard against that, so you can also have like a condition where you only buy at a lesser price than you sold. But let's not do this in this example because this is supposed to be very simple. So to make, see, we're still getting the historical data, but to make a few things a little bit more clear is the first step is you have, and I'm assuming for this video and for anything that you have functions that implement this logic, your own functions. So you have a function called, like maybe a function called update bars, which will update bars and it'll give you the less granular aggregate bars, like based on dollar bars and that sort of thing. So just as an example, you can have like 1 minute bars where, like, let's say the last bar you got was 12:30 to 15 to 12:30 20. Then the last two bars would be 1 minute intervals. It would be 12:28 20 to 12:29 20, and then 12:29 20 to 12:30 20. So these are 1 minute intervals, but they don't end on the 0 second itself. And I don't use time bars. I use some version of dollar bars. Also, some of you guys only want to do logic when a bar is like it's like an actual like dollar time bar or something like that. Or let's say you have like some filter condition like QSUM filter. So you can have like a is completed flag in addition in your update bars thing. So this would return true or false. So let's say you're doing stuff on 5 minute bars. You can say is completed is false if these intervals don't start at 0. But if they start at 0, meaning you have the whole minute interval from starting at like at the minute level, is completed would be true, and then you can run your algorithm. So just the FYI. But I try to every 5 seconds have a new bar and a new aggregate bars. That's the way I do it. Okay, so and I'm probably making no sense, so maybe I'll redo this video. In the comments, tell me how I'm doing. I wasn't planning on making this video, but I don't want to look at my portfolio because SMCI. Okay, so you extract features. Once you have your aggregate bars, you extract features. So you have an extract features method that will extract features, and that'll give you the features you need to make predictions with the ML model. But also you can with this give yourself information like take profit and stop loss targets. And then you also have a fitted ML model where you can call model.predict or model.predict prob or something similar. So I'm assuming you have these three functions implemented in some sort of black box. Here it's going to be a black box, but you're going to have your own custom implementation. So I'll show you how it works with here. So let's see if we got the historical data. We did get the historical data. So just to show you how the historical data looks for a second, it'll be like this, historical DF. So it'll just be historical data. Here I have about a month and a half of data. And the last point is yesterday at the end of trading day, the last 5 seconds using regular trading hours. Although for this example, my live bars are not using regular trading hours. Okay, so step one, I said you have to get the aggregate bars. So you're going to have this like update bars method. So if you look at it now, by the way, you have the historical DF data frame is of shape 154,000 because it's that many 5-second bars. But in your live bars has util.df real-time bars. That shape has shape 91 because we had 91 5-second real-time bars, and of course this will be 92 if you keep running it. Okay, so now the idea is whenever you get a new bar here, you want to add this to the historical data frame. Of course, handling logic so there won't be overlaps. And that will be like a big data frame with 5-second bars. And then you're going to aggregate that and create, let's say, bigger things like, let's say, 5-minute bars or, in my case, dollar bars. But I'm keeping it very general. So I have this function called update bars. And then I'm going to have historical bars df equals historical df. And then I'm going to have live bars equals real-time bars, and then I have a dollar threshold because dollar bar threshold because I do dollar bars, and 1 second. So I'll do dollar bar threshold equals dollar bar threshold. So now I have this function, and it's gonna give me a data frame of aggregates. As you see, this is not 5 seconds apart. This is in this case it's 7 hours apart, just because it's end of the day. But in general, you'll have like, this will be like, let's say 2 minutes apart, 54 to 56, 59, 3 minutes apart. It's dollar bars. Okay, but just if you want to look, the shape here is about, it's going to be way less than this. It's going to be 10,079. So as long as I have features that use less than 1079 bars, I should be fine with this amount of data. Okay. So let's actually save this in a thing. What we can call it like new ag bars df. Okay, this is just to illustrate the concept. So this is the first step where we get the aggregate bars, the new aggregate bars, and it'll be part of a callback where you update this every time you get a new 5-second real-time bar. So now to extract ML features, we have another method called extract features, and you apply it to this. So this method will calculate things like RSI, PPO, if you use technical indicators. And then I said there's also going to be like a, oops, what happened to this? Sorry guys, I must have, okay, so like I said, it'll have a close. I just did for a dummy example that the take profit is 10 cents above and 10 cents below, but you should make your own logic. So these are the aggregate bars. So I can call it DF features or something like that, or I call it let's call it features DF because later I actually do use DF features. So this is features DF. These are the features you have, and then you have a fitted model, and I save the fitted model. ML model dot predict. You can do predict proba if you have let's say a classification and you have probabilistic predictions, and then you can predict proba. You don't need every single prediction, you just need the last one. So you can do like iloc -1 like this, and then you get the last one, and let's say you don't need both the positive and negative predictions, you can just take the positive prediction. And this is the this is what, oops, what did I do wrong? Oh, it's only of size 1 anyway, so what am I doing? Oh, you need the last one. So let's do like this. Okay, so this is what you need, and this is your probability, and then that's what you're going to compare against the threshold. Okay, so okay, so now let's talk about how you would implement like what we need to do. We have this main algo loop in our on bar update callback, and what we need to this is what we need to implement. I want to make a small note that for real time bars, has new bar, in my experience, is not really necessary. But if you're doing keep up to date equals true, it's very necessary. So the step for the callback is like this. And usually I put this as part of an algorithm controller. But because this video, I wanted to keep it shorter, I'm going to talk about that in a different video. Okay, so on the on bar update, what happens is whenever you have a new bar, it does this logic, right? So it's going to create your aggregate bars. That's the update bars function we discussed above. Create features with the extract features method. Make a prediction. I called it probs cat because I'm using cat boost in this example. And then you call your on-bar algorithms. So you can have many on-bar algorithms. I'm going to assume each one has a get action method, which will do the action of your trading strategy. And I'll illustrate that very clearly in a second. Okay, so each of our trading strategies for on-bar algorithms are going to implement this on-bar algorithm class, on-bar algorithms. So I'm going to have this abstract class on-bar algorithm. It's going to take like initialization. You're going to have like a IB, which is your IB, whatever, what's this data type called? Type IB. It's IB. It'll be IB, big IB, async IB.IB. So that data type, because it'll be helpful. And then you're gonna have like a set config file. It's gonna set configs. I'm not gonna show you like config files and that sort of thing. I'm gonna just illustrate the concept. And then all you have to do is you have to implement the set config method. Usually you would read from a config file, that sort of thing, and the get action method. Those are the only two things you need to implement here. Okay. So let's now illustrate that with the example of the simple ML buy sell algo. Okay, so let me say implement it simple ML buy sell algo, which will subclass on bar algorithm. So this is going to do this. Let me just make it a little nicer, the notation. And sorry, this might be a little confusing to people. So if you have questions, ask in the comments. Like the video, subscribe, you know, that good stuff. So now let's create a class. So we're going to have class simple, we'll call it simple ML buy sell algo, and it's gonna subclass on bar. You know what? Let's call this on bar. We'll call on bar algorithm. Okay, so def init. So this is also a reminder for people who might not be used to like subclasses and that sort of thing, how to do things. So like the init, we can call the super, which is the parent class here. We're going to call its init method, and that you do by init IB, like that, because it only has one thing. And then, okay, so I'm going to define some of the variables I'm going to use in my logic. So I'm going to have something called self. I don't know. I'm doing this underscore thing that's completely unnecessary. Just because I don't want this active trade flag to be used outside this class, and that's like a convention. But I'm not the best Python convention guy. But okay, so this is a flag if the trade is active or not, because we only want to trade when we have no active trades available. And then I'm going to also have something called QTY sold. So I'll explain this in a second. So what I want to do is I want to like basically trade, let's say 200 shares at a time, and whenever and the way I know I completed a round trip is if the number sold got to 200, so I completed a round trip, and then I'll reset this back to 0. So that's just like an initial value. So then I'll implement the second fig. You should take this often from a config file. So there's like .ini and config parser. If you really want a video on that, we can talk about it. Also, I want to make, if you guys are interested, this is a buy first algorithm, but you don't really, in my opinion, you don't really want to do a different algorithm for sell first. So there's a way to do with like Python operators where you can literally translate it from buy to sell without making a stupid mistake because you're redoing your code, and I'll show you how to do that if enough people are interested. Okay, so one of the configs is the quantity, like the amount we want to trade, right? And usually you would put this in all right, usually take this from some config.ini file with config parser class. That's the proper way to do it if you're at a big company. So you have the quantity. This will be quantity to buy to trade. So that's like a config. Let's also have self.max buy price equals, let's say AMD is way under 260 unfortunately, but this is like what is AMD at? AMD is at about 147. Jeez, I don't even want to look at SMCI. So this is the max price we're willing to buy the stock. Let's say you don't want to buy the stock above a certain price. You can have that sort of thing. So I'll write max stock price willing to buy at. And then I'm going to also have something I like to do called discount from limit. This is how much less than the this is basically how much less than the current price we want our limit buy order of our bracket order. So let's say the closing price is like 146.9. So our buy would be 146.85. It would be, let's say if close is 146.9, then then our buy limit would be 146.85 in that case. But eventually I'm going to make this, I'll say, I'll write it like this, but later I'm going to change this to 0, to be honest with you guys, just to show you guys like the rest of the process. But as you see, it's like what do you want to pay for the limit, and then you're gonna have like a self.probs thresh for buying. This will be the threshold you want to buy at. So let's say you want to only buy when your model predicts 51% or above. We'll change that in a second to ensure we get some buys. We're gonna also want to okay. So this is one thing we need to implement. We also need to implement the get action method. Get action, and in this case I don't need async def. We'll make a video on async def. We'll make a video on asynchronous programming, but we don't need that here. So get action is another thing we need to implement, and this takes df features and the probability prediction. You can also make it way more general by having more than one probability prediction, like the last 10 or something, or whatever you want. Everything is possible here, but I want to make it simple for this example. So this is where you do the get action function. So let's implement the logic we wanted here. So we wanted basically if the prediction is above the buy prob threshold, closing price is less than the max buy price, and you have no active trades, then you can make a buy order. Okay, so let me do that. If prob greater than or equal to self dot probs thresh for buying, if close less than or equal to self dot max buy price. If not self dot active trade, then and we don't have the closing price, so the close would be close equals df features dot iloc minus 1. I probably made a mistake somewhere, dot close. Okay, so that's the last closing price. So if it satisfies all those conditions, then we can basically submit some sort of bracket order. So I'll do something like limit buy price equals close minus the aforementioned self dot discount from limit. I'll have take profit price equals in our case we have a thing for take profit, so it will just be df features dot iloc minus 1 dot take profit target, not the regular Target or Walmart. I'm just kidding, trying to be funny, but I'm not funny. I am funny, but not on YouTube. So like I also have a stop price target. So these are the three values I need, and then I'm gonna have this is where I'm gonna need place bracket order. Maybe I'll call it new bracket order, and it will return self that active trade equals true. Maybe I should. It doesn't need to return anything, honestly. We'll set self that active trade equals true. Okay. So we need to define this bracket order function. And I have, of course, a lot of videos on bracket orders. But let's define it like here. We can have def place bracket order. And let's do two things. Let's do self action quantity limit price take profit price stop loss price. And I have many videos on bracket orders, so I'm going to go through this a little bit quickly. So first thing you're going to do is you're going to do bracket order equals ib dot bracket order, and remember this thing takes doesn't give me auto suggestion. It's annoying. Oh, because it's called bracket order. Sorry. So this needs action, or our action is buy in this case. You should put that in your config. So maybe I'll do like this. I'll do self.action. That's in our config equals buy. Okay, so I'll do self.action here. Just to make it more general, right? And what else do I need? I need the quantity equals self.qty. What else do I need? Yeah, you know what? I don't even need all this stuff, honestly. I don't know why I have this. I only need a limit price, take profit, and stop loss. So I can do like this. So I can do limit price equals limit buy price take. And I shouldn't call it buy price because it could be. I'll call this limit price. Again, if you want to change from buy to sell and that sort of thing, I'll show you like a cool way to do that if you guys leave enough comments. So limit price take profit price equals take profit price stop loss price equals stop loss price. And let's maybe write this in multiple lines to make it more readable. I don't know if this cuts off or not. Okay, so this is a bracket order, and remember you have and let's place the three bracket orders. So let me just show you how to do that. So like you do let's say parent trade equals self.ib.place that place order. Sorry, why does this not give me anything? Self.ib. Because it should get the self.ib from here, from this super. I don't know why it's not giving me to. Anyways, whatever. That's another reason. It's probably better to do some of this stuff in like an actual like IDE. So parent trade, take profit, trade equals this. Stop trade equals this. Self.ib that place order. Self.ib that place order. Self.contract for each of them. Contract. And then let's do. We also have the order itself. Okay, so we have bracket order dot stop loss, and just to make sure I remember, this is bracket order dot. It's called stop loss, yes. And this is bracket order dot take profit. Nope. Dot take profit. For sure, I have an error here. We'll see. A moment of truth will come in a second. Bracket order dot parent, I think it's called. Okay, great. So we have those three trades, and remember, we want to now set self dot active trade to equal true now, because this means we're in active trade. So that's placing the buy order. Okay. So the other thing is you would need like a self you would need like you could put this in the config somehow. You could do like self.contract equals the contract, but you know what, let's do it in a def set contract self contract of type contract equals self.contract equals contract. That sets the contract. Okay, so we need that. What else do we need? We need now. Okay, so now whenever we make a buy order, we add this active trade flag. So we got the buy covered, right? But how do we know that we finished a round trip? We need to like handle it like we need to make callbacks for when there's like a sell order, right? So we'll do that with like a execution detail callback. So I'll do def on exec details, and usually I don't do it this way. By the way, I attach the callback to the trade itself, but in this case it actually was convenient. So I have this callback, and what this callback is going to do is going to, let's first of all say it prints some information. So I'll do fill.execution that side, that's if it's a buy or sell. It's called SLD for sell and BOT for bot, which is weird. Shares is fill.execution that shares, that's number of shares bought or sold, and let's just print let's say new side execution for shares. Oops. And this will say for how many shares. Okay. So now this is just to print info, but what we wanted is like to know if we finish like the round trip. So, and again, I'm assuming no modification of orders, no canceling, that sort of thing. But like if side equals sold, right? Then we're gonna have this self dot quantity sold thing to keep track of the number we sold plus equals shares, and then if self dot quantity sold equals self dot quantity, that means we're finished with that trade itself. We can reset the quantity sold back to 0. Self dot quantity sold equals 0, and we can now have self dot active trade equals false. So we can go to our new trade. Okay, so this is the on execution details. It also would be very helpful to have like a on new order to explain when we have a new order. So I'll do that. I'll do trade. So I'll print new order, and then I'll just print the order, I think is a good idea. create the order like this. Okay. And then let's just have a function called attach callbacks self. And this is going to do self.ib dot so we have two callbacks here. We have the new, or I don't know why it doesn't give me the auto thing. That's a little concerning. Self.ib.x detail event dot clear. So basically I cleared the callbacks in case they already were set somehow. And I don't know why I'm not getting I mean I have IB as this you know, just to help me out, I'll do something like just to help me out with the autocompletes. Does this work? Yeah. Maybe you shouldn't have that, but just because it's not giving me the autocompletes. So now to attach the callbacks, this just ensures that there isn't a callback already running, so it removes the callback. So new order event plus equals self.on new order, and then self.ib that I for sure have something wrong, plus equals on exec details like that. Okay, so that attaches the callback. Great. I don't think we have anything left for this simple method, but I probably got something wrong, so let's run this. Okay, so now that we have this function, let's create an instance of this function and let's add it to the update callback and start the algorithm and show you how it goes. So let's do simple ml algo equals simple ml by cell algo ib, and then I can do simple ml algo dot set contract. Why is it not giving me the set contract thing? It's weird. Set contract, weird. Stock, something went wrong probably. Did it work? Okay, I don't know if this will work. Dot attach callbacks. Let's see if this works. On X details not defined. Oh, self dot on X details. Okay, so now we have to define the on bar update callback. Again, I usually have this in some big algorithmic on bar algorithm controller file that will handle many such algorithms. But for now, let's just do it like this. Remember, this is what we want. We want the callback for when a new real-time bar arrives. So let me just copy and paste this and implement the missing detail. So, okay, so like now, what time is it? I have to pick up my son soon. Okay, I might have time. Okay, so so now this is the to do. We need to call the get action. So in our case, we'll call simple ml algo.get action. So we're gonna call that here, and it should work. So to start the algo, we would do first of all, we have the update event. Let's clear in case we already had an update event, and I guarantee you this will be wrong the first time. But you know what? Let's plus equal on bar update like this. Let's also add one more thing. Let's just print the print probs cat. Let's print this to know that let's say prediction prob, just to know that we're actually doing something. Okay, and I'll change the configs in a second, but okay, so now I'm attaching the callback, and let's see what happens. I guarantee there'll be an error. There's never no error when you're running the first time. Oh, okay. So the prediction probability, I mean, we still have a chance for error. Okay, so you see it's not going to buy because we're way under the prediction probability. So if you look at ib.open orders, you see we have nothing. Okay, so let's clear this callback, and let's just change the threshold from 0.51 to let's say 0.451. We want to buy. So let's rerun everything. And now let's see what happens. Ugly mess. Take profit target. Ooh, but nice Nice. What's it called? Error helpfulness. No attribute stop profit target. Do you mean take profit target? Ugh, I hate this. So my daughter is almost 3 and she loves playing with daddy the pink game, where she finds the pink stuff, um, which is all the errors I have always. Okay, so I have a problem with the take profit thing. Um, we can see what I called it here. What did I call it? So I had this, remember I had this features df here. So I called it dot columns dot to list. What did I call it? I called it take profit target and stop loss target. So why is this not working? Stop profit target, stop loss target, stop loss target, and now it should work. Great. Okay, we figured that out. But just make sure we have no open orders, just in case. Let's clear it first. Yeah, it's kind of annoying that when you get an error, it writes this whole thing. We should also make a video on the logging method, by the way, because I learned a lot from that. So I have no open orders and I cleared it. So let's see if this fix worked. So let's start over. So the prediction prob, we're above the threshold, so it should make a buy order. Don't know why it didn't make a buy order. Did I? It didn't make a buy order. Why did it not make a buy order? I have a probs thresh for buying. And I have a max buy price at 260. So what went wrong? Yeah. Something went wrong because it's obviously not buying. So let's kind of debug the old-fashioned way. So let's say let's say print prob thresh met, and then let's print under max buy price to see. Oh, it can't be here because we already got to this thing. It's weird. Yeah, I don't know what's going on. Because we should have already got to here. Print no active trades. I might have not written, not like called everything. So let's try again to restart. And let's make sure we have no open orders for a second. Okay, so now let's try and see if this helps a little bit. So yeah, so it should make a buy order. Don't know why it didn't make a buy order. It's weird. Oh, I never wrote the place bracket order. Sorry, guys. So let's add that and let's remove these annoying things. Okay. So I never actually wrote the place bracket order part. Okay. So I'd have to do self.place bracket order, and then I would do it with the limit price, take profit price, stop loss price. Why do I call it stop profit price? I'll do stop loss price. Okay, so now let's see if this works. Okay, so now let's see if this works. Stop loss target not defined. What did I get? Stop loss target not defined? That's weird. See, it's kind of annoying, the error message. Stop loss price. Asking if I mean stop loss price. Okay. Okay, so let me do that actually. Stop loss price, you're right. I guess the computer is always right. Okay. Uh, huh. You know, it's funny. I fixed it, and it. Okay, let's clear everything, and let's also IB that open orders. Let's cancel all these open orders for order in IB that open orders. IB that cancel order. Okay, so cancel. Okay, great. So I canceled all open orders here. So now let's put this up. Let's see how it works. Okay, so great. So like start from scratch. Let's now attach the callback and let's see if this works. Okay. So you see the prediction is good. We make a new order with the limit buy and then the take profit and stop loss. Remember, there's a 5-second limit, so it might not hit right away. So let's cancel it. Let's clear and cancel, and let's change the limit offset to make it actually hit right away. So I'll make the limit offset. I'll make it even negative, but this should be positive. Okay, so just to show you guys the example, you know. So now it'll be something like this. Let me show you guys how it works. So I have okay, there's a new order. And we should have filled by now. Maybe I should print the closing price too. You know what? Let's stop this and cancel orders. Let me do like an extreme example. Let me do 0.1. This will for sure hit right away. So you see, okay, so you see I have this order, and then I have the oh, I didn't run this. Okay, so because my offset is now buying at 10 cents higher than the current closing price, it should fill right away. Oh, sorry guys. I know why it's not filling. Sorry guys. It's not filling because good catch. Because this is I need to use regular trading hours equals true. So let me do use regular trading. Outside RTH equals true. Sorry about that, because this demo is in regular trading hours. So now we don't need the insane example of minus 0.5. Let's make it 0. So now let's show you the process. So now I attach the callback and run this thing, and look what happens. Because we're above the probability threshold, we're gonna submit these orders, and you see we get a bot execution. We bought 100 shares. We should have a 200 shares. So what we have open orders. IB dot open orders. Am I missing something? Yeah, I still have 100. So only 100 were filled. If you go to IB.fills, only 100 were filled. So let me check that. util.df. So only 100 were filled. So I had a partial fill, which is a good practice actually. If I look at execution, see a new bot order for now 100 more. So now I have 200 filled. So let me show you how execution. So our fills looks like this. That to list. So our fills looks like this. We have 2 bot fills, and then we'll wait for the next sell, whatever that happens. And I guess I do have some time. It's 2:40. Okay, because I have to take my daughter. So let's wait until we get like a sell at something 10 cents away. Come on, should hit somewhere, right? Moment of truth when we get a seller. Let me check stocks for a second. Is SMCI already super dead or yet or no? AMD. Ooh, AMD, nice. A little bit of a tiny, I mean, bounce. I guess we have. I don't get why SMCI is in big trouble because they haven't commented on this thing, so it's really bad. Um, so I haven't gotten to seller yet. I mean, I made it 10 cents apart, right? So like if I do I have real time bars -1. Let's just see what the actual price is. So we're at 147.11, and we're trying to get oh, we should have our stop order soon, right? Because so what is our open orders? I'd be that. Oh, to be honest, you know what a stop order is, right? A stop order becomes a market order. So this is never going to hit pre-market because stop order becomes a market order once it goes down. So this is never going to hit, okay? So let's cancel this until we get in. Let's just show you like when we get like a take profit example, because a stop loss example will never hit. Because why would it never hit? I'm pre-market, and in pre-market there's no such thing as a market order, and a stop loss becomes a market order when you get below the stop price. So let's start over from scratch, and let's just hope that the take profit wins first in this example, to just illustrate the process. So we bought 100 shares. As you see, I'm printing out the orders we buy. It's funny, I'm getting so many partial orders. So we just need a 10 cent jump to show you the process. So I bought 100 shares. Let's wait until we buy another 100 shares. Ugh. Come on, man. You know what? Let's. I have no patience. Let's make this really easy. Let's actually let's make the limit like plus like a negative amount, so it'll trigger right away, and then we're gonna be let's okay. Sorry. Let's keep the limit as is, but let's purposely make the take profit price equal to the stop loss price, just to show you guys like the thing actually working, which is what I really want you guys to show. So I'll make this like -100 or something, -1 or something. Okay. So let me just show you, because I want you guys to see the algorithm in action. So now let's start. I just made the thing a little bit more clear. So update event. Now let's go. Okay. So we're printing the prediction. We have the new order. Let's see if it gets filled. When it gets filled, not filled yet. Dang, I'm really losing my patience with this. Okay, you know what? Let's make it fill right away, just to show you guys the example. Just let's make it completely fill right away. We'll make the discount a negative value. It should always be positive, of course, 0.05. The take profit would be like hit right away after that. So let's see if this works. And I guess this was good we did it pre-market, because it showed you like weird things you might not remember. Like stop losses are only valid during market hours because they become market orders. But see, look, I have a bought, sold, and bought and sold. It keeps going back and forth. Why? Because whenever you have the sell, the quantity changes to 0. So I just wanted to illustrate that this algorithm works. We can make it more general. Here we have 100. So we need another sell order for 100 before we can get to the next buy order. So I'll show you. But like this is just showing you like an example, and hopefully this is a base to make it more general for future videos. But anyways, I hope you enjoyed. Please please like and subscribe. Although if you're listening this far, you probably have liked and subscribed. And good luck. Have a nice day, everyone. And let's stop this algorithm because I look how many things I bought, like a drunken sailor. Anyways, have a good day, everyone.